Hello and welcome. My name is Dimitar Nikolov and I'm going to show you how to get started on paper 1 for the class in this video. The first thing we want to do is go to the course website and to the paper 1 page. This has the requirements for the paper as well as some helpful guidelines. So you'll be working on a 2-page paper on one of the technologies that were assigned to you for tech list 1 and 2. So you can pick any one of those assigned to you, and your goal is to provide a little bit more detail and context on that technology. So you want to summarize it briefly, and then you want to think about questions like what kind of problems has it been applied to successfully, or what kind of infrastructure does it need, or how it relates to big data, those kinds of things. So we have some questions here that you can use as a guideline. This is not an exhaustive list, so you can come up with other questions that you can address in your paper. The structure of your paper is very simple. It should have an intro and a conclusion, and then you can add sections to the middle as necessary to make the paper easy to read and clear. Your paper should be written as a scientific paper, meaning that your goal should be to inform and to give context. So don't just paraphrase what is on the website for the technology. You want to dig in a little deeper and look for other information, especially scientific papers written on this technology. You can use Google Scholar to find such papers, and if you can't find any, you can still try and find extra information like some benchmarks or something like that. So your goal is to dig in a little bit deeper. On this page, there's also a link to a repository where you're going to submit your work. This is a different repository from the website one that you're familiar with, so you'll have to fork it and clone it, and we'll go over that in the video. There's a README file in this repository that is going to be helpful as well. It has details on some of the more technical things that you'll need to do, like setting up Git, which you'll already be familiar with, but also running some of the setup tasks. And we're going to go over these in the paper. Before we do that, there are a couple of prerequisites before you start working. One is you should have virtual env installed on your machine. If you did TechList 1, you probably already have that. If you still need to install virtual env, you can go to the course website and under lectures, and then in the system track there's a Linux shell video that shows you how to set up your environment, and it has a section on installing virtual env and using it. So take a look at that. The second prerequisite is that you need to have LaTeX installed on your system. And on Ubuntu, which I'm using here, it is very easy to install. It's one command. On other operating systems, we've included in that README file on the repository, we've included some LaTeX implementations that you can use on OS X and Windows, as well as an online LaTeX environment. So you can take a look at this README and the links here. But if you are setting this up on Ubuntu, all you need to do is execute this command to use the apt package manager to install the TechLive full package. I'm not going to do this on my machine because I've already installed it. When you install it, keep in mind that this is a really big package, is over 3 gigabytes, so it will take a while to install. But You don't need to do anything else other than run this command and agree to the prompts. Okay, so next we're going to look at cloning the repository and then setting up the paper. The setup of the repository is no different from the classes repository that you used in TechList 1. So we need to fork and then when the repository is copied to our account, we need to clone it. So I'm going to use the SSH protocol, and on my computer I have a GitHub Cloud Mesh directory, and so that's where I'm going to clone. So git clone, and just like with the classes repository, we want to make sure that we set up the upstream remote. So if I go into the repository and check what remotes exist, I only have origin, so the copy of the repository that is on my account. I need to add upstream so that I can synchronize with changes that other people in the class commit. So I will just go to the Cloud Mesh repository, the one that I originally forked, and I'm going to copy the address, and then I'm going to add another remote called upstream. So git remote add, and now I can see both origin and upstream. So every time you want to commit something, or every time you want to start working on your paper, you can synchronize your copy with what's on upstream by doing first a git fetch. This fetches all the branches that are on the upstream remote, and then you can rebase to the master branch of upstream, and this will keep all of your files synchronized. Okay, so let's look at what files come in here. There are directories for paper 1, paper 2, and the project, so all of these things you're going to submit in this repository, and each of these directories will have a subdirectory with your HID that you need to create. So we're going to do this for paper 1, and you don't actually create the directory manually. You're going to run this setup script, and it's going to create the directory for you and do some other things. So let's see how to use this script. To run it, you can just type /setup, and this tells us what the correct way to invoke the script is. So we need to provide two arguments, the type and our HID. So type can be one of paper 1, paper 2, or project, depending on what we're working on, and ID is the HID. So I'm going to put in setup paper 1, and my HID is this one. What this does is it creates a directory under paper 1, and it also clones a template that you're going to use for the paper. So let's see what is in the paper 1 directory. There's my HID. When you do this, there might be others. And in this directory, I have a template that I'm going to use for the paper. So there's a report.tech file that will contain your paper. There's a references file where you're going to put your references just like you did in revs.bib in TechList. there's a make file that we're going to use to compile our LaTeX template, and there's also a README file that is going to be important, and you will see how. For now, let's run make to compile the report. And you can run make view to open it. And so you'll see that this has quite a few things. It shows you how to add a list of authors with affiliations, how to add an abstract, how to add figures or tables or math equations or code. You're not going to need all of these things, but the template shows you how to do all of them. Now, when you compile the LaTeX, you're going to see that a lot of new files were created. These are auxiliary files that we don't need. And so if you run make clean, it will delete all of these auxiliary files. The repository is already set up so that it ignores all of these files, but if you want to keep things less confusing, you can run make clean to get rid of all of them. Okay, so let's look at the report.tex file next and see how to work on the paper. Before we continue, I want to point out that when I ran make, I hadn't activated my virtual env, and my compile worked because the default Python installation here has the necessary modules installed, but we shouldn't count on that. We should always make sure that our virtual env is activated. And so to do this, I'm going to execute the activate script in the virtual env directory like this. And so if you ran into any issues and your compile didn't succeed, this is probably why. Okay, so to edit LaTeX files, I'm going to use Emacs. You can feel free to use whatever editor you're most comfortable with. So I'm going to open report.tex, and I see a lot of syntax that you may not be familiar with. In this video, we're not going to go into detail of what all of these elements are. Instead, in the description, I've put two links. One is to the LaTeX lesson on the course website, and the other is to a quick start guide to LaTeX. And both of these things are pretty short, so please go ahead and take a look at them. They will tell you about the basics of LaTeX and the most important things that you need to know. Instead, in the video, I'm just going to demonstrate the workflow that you're going to use for the paper. Now, in a LaTeX document, there are two main parts. One is the preamble, which is from the top of the document to this begin document directive. And this contains things like the title of the paper, authors, and things like that. The main part of the paper contains most of the content that a reader would see, like the sections and figures and references and things like that. So what you should do is have the content of this template handy. It's a lot of things, but there are useful examples in it. So one thing you can do is copy this file just so you have the original version of the template that you can copy and paste from, or you can leave it as is and start writing your paper, and then in the end remove the parts of the template that you don't need. And that's what I'm going to do here. So I don't have a paper, but I'm just going to generate some dummy text. Okay, so I'm going to generate 10 paragraphs of text here, and I'm going to copy them in my paper. Okay, so I'm going to copy all of this right under make title, and here's my text, and I can maybe add some sections here, like an introduction, and let's say we have an architecture section, and maybe a features section, and maybe we have a subsection like performance, and so on. So you can paste your information here, or you can just start writing, and I am going to use the convention that we did in TechList, so I'm going to make sure all lines are no more than 80 characters long. In Emacs, this is very easy to do with escape Q, and I'm going to save and recompile. It's a good idea to recompile often, because if you introduce any errors into the code, it will be easier to find them when you've made only a small change. So get in the habit of making a few changes and then running make again to make sure that everything runs correctly, and then you can make view again to make sure that everything still displays correctly. So here's my new sections here. Okay, and so you still have the template, the original template content here. So you can copy and paste. For example, when you want to add a figure or a table, you can copy the relevant section from the template into the sections that you put in, and then change them to fit your purpose. And the documents that are linked are going to give you a little more detail on these elements, so that you know, you have a good idea of what needs to change here. One thing I want to mention is that references work a little bit differently in LaTeX than they do in restructured text. So in restructured text, the cite command is different. So here in LaTeX, we have to, if we want to cite a paper, we have to use \cite and then put the identifier of the paper in squiggly brackets. So let's say I want to put this citation somewhere in my introduction. Let's say over here. I need to put the cite command like so, which is different from what we did in the web page for technologies in TechList. When we cite, we have to make sure that the references exists in our references file. So I will open references.bib in the same folder as report.tech, and here I can see my reference. This is where you should add additional references as you find them for your paper. Let's switch back to the report. So you can write your paper in this way. So introduce the content, adapt whatever you need from the template, and then whenever you're done, so let's format these paragraphs properly. So after we've done that, let's say that we're done. So what I'm going to do is delete all of the, or almost all of the contents that are part of the template. So I'm going to delete everything up to this bibliography command here. So this is just a comment, I can delete it, but this bibliography command is actually what tells LaTeX that references.bib is where all of our references are stored. And then I can delete everything that comes after that, like the author biographies, and just leave the end document at the end. So I'm going to save this and run make again to make sure that I didn't introduce any errors. And if I look at my text, I don't see any of the old template content. So this is the basic workflow for using this template. Just keep it around so that you can copy and paste relevant commands, and at the end you can delete everything that you don't need. Okay, so we're going to look at one more thing before we're done. Once you've written the paper and you want to submit it, one thing you can do is first test that your submission is okay. And you can do this using this, there's a test papers file in the root directory of the repository. So over here, there's test papers, and I can run test papers and specify the directory of the paper that I want to test. And so I'm going to put in paper 1 and then my HID. And right now the script tells me that there's an issue, and the issue is in the README file in this directory that I mentioned earlier, but we didn't look at. So let's look at it in Emacs. This README file contains some information that we'll need for grading. So when you're ready to submit, you want to enter a date here of when you are done. This is more for us to know that you are done, and it's okay for us to grade it rather than anything else. We can always check when you did your commits. And then you want to fill out other fields like the name of the author, your HID, PID is a project ID that right now you don't need to worry about. Also, you need to enter the GitHub username, and you also want to enter where your report or paper can be found. And this is likely not going to change for you, so it's always going to be report PDF. And proposal here is relevant to the project, but you don't need to worry about it now. So make sure that you've entered, you've updated all of these fields, and then if you run that test paper script again, you should be good to go. So from here, we want to commit our homework. So the first thing I'm going to do is make sure that I'm synced with upstream. So I'm going to fetch upstream in case any changes occurred, and then I'm going to commit my file. So I can check what I need to commit, and so I need to add this whole folder, paper 1, my HID, and I can look at the status again, so it will add all of these files, and then I'm going to commit, and I'm going to use the same conventions that we've been using before. So I'm going to put new user and paper1 submission for, and I'm going to enter my HID here. Okay, so before I push, I want to rebase. We're up to date, so I am good to push to the origin repository master branch. And in this repository, you're very unlikely to encounter any conflicts because you're not going to be editing any files together. You're mostly going to be working in your own folder. So when you do commit and then rebase, you're not going to find any conflicts unless you did something wrong, like work in a classmate's directory. Okay, so from here, all you need to do is go to GitHub and generate a pull request. So I'm going to go to my copy of the i524 repository and create a new pull request. I'm going to make sure here that all of the changes make sense, so I can look at everything that was added. There's going to be a lot because as part of the template there are some style files that you're never going to edit, but we want them to be part of the template anyway. So you're gonna see a lot of things here, and it's not going to be just what you worked on, but that's okay. So I'm going to create my pull request, and I'm going to wait for someone to merge it. And this is it for your submission of paper 1. If you have any questions, please let us know on Piazza. See you next time.